3, we're given AB is congruent to CD. My underline took over my segment line there, so there's my segment AB. Segment AB is congruent to segment CD as it's marked on the figure here. Segment AF is congruent to segment ED marked on the figure here. And angle A and angle D are marked congruent on the figure here. We're supposed to prove that triangle BFE, which is BFE, that triangle there, we want that to be congruent to triangle CEF, which is this triangle here. Okay, recently we've been doing a lot of problems where it says show that, verify that, that kind of thing. This is one that actually says to prove, so we're at a formal proof here. I'm just going to go 2-column proof on this one. Before I write a 2-column proof, I like to kind of think it through and see what is true, so I kind of have an idea of how I'm going to write it. So, based on what they tell us, that these sides and those angles are all congruent, can everybody see that this triangle right here, triangle BAF, and this triangle here, triangle CDE, my side angles are congruent? All right. So let's start with that. So I'm thinking right off the bat, maybe if this thing will erase. Thinking right off the bat, write the given information, state the congruent triangles. Okay. If the triangles are congruent, that means all parts of the triangles are congruent. So I know that BF is congruent to CE. That's useful because those are sides within the triangle I'm trying to prove congruent, right? So just like that, the BF and CE are congruent. There's a couple sides in the triangles I'm trying to show congruent, all right? I also know that FE is congruent to itself. Why? Why is FE congruent to itself? Reflexive property. We have overlapping triangles. That happens quite often where they have a shared side. FE is a part of both triangles, so that equals itself, congruent to itself. It's reflexive property. And just like that, I got two sides, so I've got side, or side, angle, side out there as possibilities of what I can use. So with that in mind, if it's side, angle, side, I need this angle down here to be congruent to this angle over here. Is there anything right off the bat telling me that that's true? I don't see anything myself, all right? But can we all agree that this angle, let's call this angle 1 and angle 2. Would everybody agree angle 1 and angle 2 have to be congruent? Because of the CP, CTC, the two congruent triangles here, ABF and DCE are congruent, so 1 and 2 are corresponding angles. So here's my thought process. This is the part that's going to take the longest part of the proof here. But we know 1 and 2 are congruent. I want to show that 3 and 4 are congruent. Right? Can everybody agree that 1 and 3 makes 180? 2 and 4 makes 180? So 1 and 3 and 2 and 4 equal each other. 1 and 2 can be replaced as the same thing. So you take 1 and 2 out, you're left with 3 and 4, they should be equal. So that's going to take 4 or 5 steps to go through the whole process there, but I want to state congruence of angles. I want to state 1 and 3 make 180, 4 and 2 make 180. I want to do a little substitution, and then subtraction, and then I'll be left with 3 equals 4. All right? And once I get that, I got side angle, side congruent, so that's my thoughts. So, and again, before I start writing the proof down, that's kind of what I want to do, is I want to walk myself through the proof, kind of see how I'm going to write it, and then I'm ready to go. So, one thing I did do here that you need to start doing yourself if you want to save some time and energy on these proofs, angle 1, 2, 3, and 4, instead of calling it angle AFB, I can say angle 1. Instead of saying angle DEC, I can say angle 2. Multiple angles happening at those locations. So if on my figure I mark up the figure with specific things to refer to the angles as, when I write the proof I can use those descriptions. Otherwise I have to write the 3-letter angle name for this angle and this angle and this angle and this angle. It gets to be this big ginormous mess on my paper. It's harder to look at. So feel free to, when you draw the picture, put angle numbers on there so you can refer to angle 1, 2, 3, 4. It's just easier to write proof. So, if I go ahead and set my proof up here, so statements, that's big, making a big statement. Statements, reasons. So, again, I'm starting off with my given information, so I'm going to start off by saying that segment AB is congruent to segment CD. Segment AF is congruent to segment ED. And angle A is congruent to angle D. And that given information, that side angle side given to me, immediately leads me to the ABF and DCE triangles are congruent with one another. Remember when we're writing our congruent statement for triangles, triangle ABF, it is very key that I get the order of congruent, of the corresponding parts in the right order. So A matches D, A's first, D is first. A, B, and C, D match, so A goes to B, D goes to C, and then B goes to F, C goes to E. So there we go, and they should be congruent by side, angle, side. And that congruent statement led us to specifically two facts here. Fact number 1. Side BF and side CE are congruent, and fact 2, angle 1 and angle 2 are congruent by CPCTC. So BF is congruent to CE, angle 1 congruent to angle 2. Now keep in mind the theorem says corresponding parts of congruent triangles are congruent, not equal. Right? So I can state the angles here are congruent to one another, but my task involved getting things equal to each other, right? So I need to do some substitution. Substitution requires equations. Congruence is not an equation. So I'm going to go ahead and state here, right underneath this, after I stated the congruence of 1 and 2, that the measure of angle 1 equals the measure of angle 2, because again, we want to be in an equality world instead of congruence world. I want you to remember, because we haven't used this one recently, anytime you have a statement of congruence and you want to state equality, it's because of the definition of congruent angles. That definition goes either direction. So if I'm in congruent world, I want to be in equals world, I say because of that. If I'm in equals world, I want to go back to congruent world, I say because of that. So either way you go with that statement, definition of congruent angles, you're either stating congruence leads to an equality, or an equality leads to a congruence. Next, I want 1 and 2 to be involved with the angles that I care about, which are 3 and 4. So 1 and 3 make 180, 2 and 4 make 180. That's what we want with next. Why is that? 180 in straight line, perfect. AD is a straight line, angles 1 and 3 form that straight line, angles 2 and 4 also form that straight line, so 180 degrees in a straight line. What?
There's supposed 1 and 3, 2 and 4.
Oh, thank you, I got my numbers mixed up. 1 plus 3 equals 180 and 2 plus 4 equals 180, my bad. Thanks for the correction there. So 1 and 3 make a straight line, so 1 and 3 add up to 180, 2 and 4 make a straight line, so 2 and 4 make 180. And what you're going to notice here, which again happens quite often when we do these straight line deals, 180 degrees, 180 degrees, we have two things equaling the same thing, which means they equal each other. So measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 4. That's substitution. And the plan I had going in was this. I'm using this fact here, this yellow highlight here. 1 and 2 are equal to each other. I'm going to take this angle 1 out, and I'm going to put angle 2 in place of it. That's another substitution. Now, it is back-to-back substitution, but it's done kind of differently, so I'm going to use different lines to describe it. It's not wrong to put them on the same line, but if I'm stepping it down to make a substitution happen, then another one to make what I want happen, usually I go a couple of lines to do it. So 1 and 2 are the same. I'm changing measure of angle 1 to measure of angle 2. And the whole idea there was if I get an equation with angle 2 on one side and angle 2 on the other side, or take for that matter, I could have said angle 1 and angle 1, as long as these are the same. I could have just easily said measure of angle 1 here, measure of angle 1 there, whichever, change one of them. So they're the same. At this point, since I have measure of angle 2 on both sides, subtracting that number, whatever that number should equal, will make what's left over measure of angle 3 equals measure of angle 4. Which is the subtraction property of equality. And finally, all that work, and again, it took quite a few steps there to get to that point, but now I know 3 and 4 have equal measure, which means that 3 and 4 must be congruent. So I'm going to say angle 3 is congruent to angle 4. Why is that? I know the angles are equal, so I know the angles are congruent because of what? Definition congruent angles. Again, if I know congruent, I want to say equals, it's because of definition. If I know equals and I want to be congruent, I know it's because of definition. So, definition of congruent angles. Finally, I'm going to erase this stuff real quick because now we get some better information and get a better figure. BF and CE are congruent, that's right here, right? Now we know angle, this was angle 3, and this was angle 4, right? We know 3 and 4 are congruent, right? That's what's written right here. And finally, FB is congruent to itself. I haven't written that down yet, so I need to write that down. So number 10, FE is congruent to FE because of the reflexive property. All right, so finally, if FE is congruent to FE, so all of a sudden now, I've got side angle side congruence for these two triangles. So number 11, triangle BFE is congruent to triangle something. So BFE is this one. F and E correspond to one another, so E needs to be the middle letter of this one. This side matches this itself, so this angle should equal this angle, so B and C should match up, so C is in front, and the other letter is F. So CEF, and that's by side angle side congruence. Our task was to prove that fact, so we're done at that point. Okay. Your proof is done when you have stated down here what that says there, and everything you had up to that point justifies everything you've done.